So welcome to the Bluffer's Guide to Elitist Jargon. What can you expect in the next 50 minutes? So as this is the community night of JAX London, we're going to give you an introduction to jugs from our experiences. We're also going to try and go over some of the business jargon that you guys might come across on a daily basis. We're also going to go across some Java jargon, and we'll also talk about some computer science jargon as well. So what is a user group? Well, it's everybody here. It's the people that make it up. In London specifically, it's a LJC, and we're sort of partnering with the JAX user group tonight. So welcome to the London Java community.
Hi, this is my first time at LJC developer sessions. I don't think I've ever met before. My name's Richard.
Hi, Jim.
How's it going, Jim?
Yeah, not bad. So let me introduce you to some of the types of people that we see at our jug.
Interesting.
So the first one is the wanderer. This is the guy or girl who walks into the back of the room, takes a quick look around, and walks straight back out again. So this person, or these people, we've kind of like tried to counteract this from happening by putting greeters on the doors and to try and make a friendly face. But this is still something that we see time and time again.
Who else do you see?
We see the alcoholics, Richard. These will be the people that are hanging around the bars well after closing time, probably need guiding to a taxi, and generally just racking up the Atlassian points.
Do you have those little AA cards that you can hand out to say, here's your nearest meetup, go to them? That would be a really good idea.
That's your business card, right? So here's the other one, the unwilling other half. So this is the person that will accompany somebody along the first time that they come along to a user event. And we do welcome anybody along to these events. However, some people are less willing to come along than others.
Meetup.com stalkers?
So you might not be familiar with this concept, but it's something that I've observed over the last sort of 2 years at the LJC. We started using meetup.com to advertise sessions and get people involved, generally just as a, here's an event, come along to it. We then noticed that a few people were turning up that had, well, pretty much no interest in Java whatsoever. And when I approached one of these people, say, oh, how did you find out? Well, your event said it had free food and beer at it, so that's why we're here.
At least they're honest. You've got to give them that. Absolutely.
So people in the LJC will be familiar with the jug leader or recruitment agent. So these are the guys that generally run the jug, and although it started out from a recruiter, and what a great job he's done, it's kind of now spread out amongst a group of people that lead the LJC. So going on from that as well, Richard, you have the enthusiastic job seeker. So these are the people that come along looking to be hired, looking for jobs and general guidance on their career, and just like everyone else, they're welcome. The Passionate Vim Advocate. So, let's welcome the Passionate Vim Advocate to the stage.
So, as everyone knows, Vim is the only true editor out there. Some people like Emacs, which is rubbish. Some people like IDEs like Eclipse, even more rubbish. Basically, unless you know how to use Vi, you'll never be productive in a production environment. And you should have memorized the Java API anyway, right? So, elite hackers use Vi, and you know, I just recently built a 300,000 line of code system just using nothing but Vi the other week, actually. Yeah, really easy.
Richard, this guy sounds absolutely awesome. He's got the detail in the kind of thing that I might be looking to recruit for. Have you heard of this guy?
No, I've met this guy before. He's a real bluffer.
Oh, really? Hey, Vim Advocate.
Yeah.
I think we're going to give you an on-stage job interview to see if you'd be suitable to come work at my large corporation.
But why would I want to? I'm a CTO of a small hip tech startup, so like, you know, why do I want to interview for you?
Well, let's see if you've got the bottle to actually to take it on.
Ask away. Easy.
So let's ask a question on source control management.
Sure.
How would you do source control management?
Well, we have, I personally like to use a lot of backups, very secure backups, off-site backups. It's very important to make sure that you've got your source code synchronized safely away somewhere.
Okay, so on a more technical level, how would you do that?
We use really advanced flash storage techniques, yeah.
Flash storage techniques, this
Yeah.
sounds kind of interesting. We have a lot of those in our infrastructure plant. How do you use that?
Well, we like to make it really secure, so I prefer to use the very secure sneaker net. You have to ensure that your source code is protected by physical security. Yeah.
Okay, this is sounding a bit confusing. So what do you protect your storage in?
A secure USB stick. Yeah, I take that home.
As a startup CTO, you must be used to answering this question. How does that actually scale?
It scales really well because everything comes through me in terms of code reviews and things. So yeah, I am the single point of code quality and things. So yeah, it works fine.
How many USB sticks are you up to?
13, I think. Yeah. Labeled from 1 through to 13 at the moment. Yeah. But they're really cheap. It's a cheap solution. Not like paying for like Atlassian or something like that, which is really expensive. We're a lean startup, so we've got to cut costs.
Interesting. So, let's think of another job interview question for you, Martijn. Why don't you tell us a bit about garbage collection?
Garbage collection, well, VMs just do it for you, and we don't have to worry about that problem anymore. That was solved by some research by some old fuddy-duddies in the 1980s, and we don't worry about that stuff anymore.
Richard, I'm starting to get a sneaking suspicion that this guy might actually be a bluffer.
I really do think he's a bluffer.
Have you got any further questions that you want to throw at him?
No, I think we've established he's a bluffer.
I'm going to stay here and prove you guys wrong.
So what's it like to work in a large corporation? Well, it can be a lot of fun. There's a lot of money that gets invested in technology and projects there. However, there's also a lot of politics and red tape that you can kind of come across. There's also a lot of buzzwords. So the buzzword bingo. Raise your hands if anybody's actually used this on a conference call. I see a few people. So of those people that had their hands up, what favorite buzzwords do you have that we might have missed off this slide?
That's the voice of experience.
Dovetail. Absolutely.
Do you think you can take all these words in one go and make up a big sentence out of them, Jim, that's got coherence?
I think I might have the professional skills to do that, Richard. So what we're going to do is reach out and touch base after this event, and we'll circle back around to make sure we've got the bleeding edge technology. We're going to have to make sure we've got the correct synergies to leverage so we get the cross-pollination, because without that, we'd really be flying blind.
Brilliant.
Maybe you should take my job. Maybe you are more qualified to be a CTO.
So why should we care about buzzwords? Well, I think the first point is that it increases the complexity of the problem domain. So when we're talking to or between each other, if you're kind of at that level where you know the buzzwords, then you're going to understand clearly what's going on. If you don't understand, then you're going to be lost very quickly in an array of terms that mean nothing. It causes a lot of confusion when you're specifying requirements. So not having precise language and buzzing things up can really start to drag you down when you come into actually implementing stuff. You forget what context you meant the buzzword in when you originally started. When people start the team, if they don't know the buzzwords or the acronyms, then quite often it'll take them a lot longer to get up to speed with what's actually going on.
You mean they'll actually be flying blind, Jim?
I mean, absolutely, they'll be totally flying blind. And I've actually seen it where in-house you start having wikis where you have a list of acronyms and words that mean different things that people just kind of have to get to grips with before they can even start to understand the problem domain. And seeing as though we're in London, financial terms and financial markets are a complicated problem domain as it is. So you basically got financial terms like exchange. If you say that to someone, they'll pretty rapidly get confused with what you're talking about if they haven't worked in finance. And an exchange is just a marketplace. It's where people go to buy and sell things. What about arbitrage? That's another complex term that people drop in when they're talking about trading systems. Well, it's just basically this is actually from a US talk, if it's cheaper to buy Best Buy or PC World and you sell it on eBay for more, then you found an arbitrage opportunity. So what does it mean to execute or hit something? Well, it just means you buy or sell it. And what about a hedge? Well, basically, you're just covering yourself if everything goes wrong, which obviously people in finance are great at doing. So as you can already see, these are terms where it's already complicated enough without adding the buzzwords on top of it. And then what about accounting? Accountants have lots of lovely terms that they like to use. I've just finished filling out my first company sort of tax return thing, and all the different boxes there are massively confusing. It's very hard entry level for any of you to actually come and just fill out a basic form that says that they've had 9 billable expenses and 9 incomes. So what's an acid test ratio? Well, it's just basically if things really hit the fan, then it's assets that you can quickly convert into cash. So Martijn, your USB sticks that have some nominal value, you could probably keep to buy yourself a few rounds in at the bar.
Well, as long as I took the source code off them first, because security, Jim, security is very important.
What about debts? All debts are bad, but essentially a bad debt is where someone is never going to pay you back. And what are intangible assets? Well, they're long-term values with no physical identity. So the things that we all love, like patents and trademarks or brands. And Martijn, another one that you'll know a lot about being a CTO, startup guy, bootstrapping.
The desperate things you do to keep your company alive. And hopefully you keep them off the internet.
Yeah, that's way too much business talk for a tech conference, Jim.
Yeah, I can see a few people falling asleep / trying to sneak out to the bar. So because I've been in sort of large corporations, I think I might have lost my edge, Richard, at things that are a bit technical. So I'm going to use your expertise, and we've got a CTO here to help us as well. Can you tell me, what's this sunspot stuff?
Do you mean hotspot? You're a CTO, you must know what hotspot is.
Hotspot, yeah, it's the place where where it gets really hot on the CPU because so much code's running on it, and the temperature gets really high.
Brilliant. This man's a genius. Or alternatively, it's a compiler that operates at runtime. And first interprets your code whilst you're going on, finds certain pieces of code which are regularly, frequently called hotspots, uses information that it builds about that from a runtime profile to generate code more efficiently whilst you're going along, and focuses on only compiling the small parts, the actual hotspots, that get frequently executed, rather than compiling everything.
So when I want to write fast code, I just use a decent language like C++. Where does this have advantage?
Sorry. Where does this have an advantage? Yeah, well, because you're getting more information about the program's execution at runtime, you'll in theory be able to generate more efficient code about it based upon your knowledge of the way the program executes, which you wouldn't be able to do with a static compiler.
My code's always fast, though.
And very hot, apparently, as well.
Very, very hot.
So I was running late this morning because I had a bit of a hangover, and I noticed something called lambdas in the presentations from this morning. What are those about?
It's a function without a name. So the idea is that instead of taking code and fiddling with little corner cases here and there, instead of doing that in order to have a complex way of writing a generic function, you can pass in some function that does perform an action. So in order to be able to succinctly write code that has this kind of style, you need a function that's anonymous without a name. And in order to be able to usefully use it, you need to be able to capture variables from the surrounding state and have a closure.
I always thought that if you wanted to change, genericize a function, you just add more if statements or switch statements to take care of each new case as you add. Isn't it easy to read?
Maybe the way you do it. Mike's cheering as well. He loves that. But that's not really the way you should be doing it in 2012.
Okay, I'll take it down. That's good.
We're teaching the CTO something.
So things are complex enough. Why would we even bother with adding more complexity into the language when the if statements will just do? Where does this give us some advantage?
Really, the situation that people are targeting is parallelism. So the idea is that in order to be able to pull out the concept of doing that parallel decomposition away from having the programmer, having it from every day-to-day users, and put it into the libraries, you need a way of bundling up the code that you're going to have parallelized, and that's where the Lambda function comes in.
Makes sense. It does sound a little bit abstract, though, and going back to some terms that I remember from university, is it a bit like an abstract syntax tree?
Not really, Jim. CTO, do you have some understanding of what an abstract syntax tree is?
Yeah, there are those cool trees on the Isle of Crete. Highly recommend it. Go to Heinz Kibutz's concurrency course, and there's these really cool trees you can climb, and I'm pretty sure that's English for the name of the tree in Greek.
Sure, those aren't eucalyptus trees or...
No, that's definitely them.
Okay. Well, an abstract syntax tree is a way of representing a program as a tree. So you kind of use this inside of a compiler. So once you first parsed your source code, instead of having it from a big string, you're trying to convert it into effectively like an object graph inside your program. So the concept is that a node in this tree is a specific construct in the program. So it might be like a variable like x, it might be a literal like 1, it might be something that combines the two, like say plus, for example, a binary operator. And then the edge in this tree represents the syntactic nesting of these elements within the program. So here's a weird example. So here's an interesting, crazy snippet of code, which is not crazy at all. Int x equals 2 plus y. And on the right-hand side, there's an example of the Eclipse AST view plugin, which shows you how the AST inside Eclipse works. So at the top, you've got the variable binding statement, so that's the overall construct. And on the left-hand side, you've got the x, and then inside that, you've got 2, and then plus, and then y. So it works like a tree.
Looks like you've got a few L values going on there as well.
Yes, that's another interesting term to use. So weirdly, compiler writers differentiate between things you see on the left-hand side and the right-hand side of an assignment statement. So on an L value on the left-hand side, an R value on the right-hand side. Now, it's interesting, because if you're putting it on the left-hand side of the assignment statement, it's something you're writing to, but if you're putting it on the right-hand side, it's something you're reading from. So that's the L val, R val.
I would just call them left and right, but
Do you know anything, Jim? What about concurrency primitives? What's the countdown latch?
So it's an interesting question, and sort of based on the code that I've been reviewing over the last few weeks, people still don't quite get this, especially anything in java.util.concurrent. What I see is a lot of things where people are still synchronizing and dropping down to the lowest levels of the API, and inherently they get it wrong. I see Martijn's eyes lighting up as he recognizes something that he does at the end of the stage there.
But you just put the synchronized keyword around everything and everything's safe.
Sure, if you want your code to run, well, slower than normal.
Buy more hardware. Done.
So what does a latch do? Well, it's one of the sort of available objects in java.util.concurrent, and the idea is that here you can hold up all threads until they hit a certain point, and once they hit that, then the rest of the program can continue.
Memory barriers. Do you know what a memory barrier is?
I don't.
Do you know what a memory barrier is?
No, I'll confess I don't know anything about this. It's low-level details that I shouldn't concern myself about.
It's an interesting perspective. So it used to be the case with CPUs that you had a really well-defined ordering of how writes happened on memory. So back in the old days when everything was a single core and you only had one thread of execution actually happening at the same time, you kind of didn't really need to worry about the way the ordering of these operations on memory happens. But actually, as it turns out, CPUs in the mid-90s started reordering instructions under the hood. So something that looked like it was a single atomic operation from the programmer's point of view actually would end up consisting of a sequence of smaller operations when it came to executing them on the CPU. And that was fine for a while because you're only doing things on one core. But nowadays, when you start looking at this kind of view holistically, you've got to worry about the ordering interaction between things executing on one core and things executing on another. So you need to worry about the ordering of those memory writes. So if you don't get it right, you end up changing the behavior of multi-threaded programs. So there's, interestingly enough, in Java 1.5, they threw up a JSR that changed the memory model, which made sure that the volatile keyword actually enforced a restriction on the compiler and on the execution ordering to not reorder things beyond certain restrictions. And the memory fence is the kind of low-level CPU instruction that ends up implementing these kind of things.
So I think in Java and in business terminology that we've covered, there's a lot of complex terms that cloud our domain. Richard, you recently graduated with a PhD, so it doesn't have anything on academic jargon.
Academia is full of brilliant jargon, amazingly making very, very simple concepts incredibly complicated.
So I want you to give me a revision session on some of these.
Go for it.
What's a linear regression?
So it's a really interesting example. You've got your, here's a graphical representation of a bivariate linear regression. So a regression is the relationship between some variables. And a linear regression is when that relationship basically looks like a straight line if you draw a graph. It's not that complicated.
Yeah, it's just like I was telling you the other day at work. Remember when I was teaching you about statistics, Richard? Yeah, just a straight line. It's like a 2-year-old can draw that.
A 2-year-old.
It's easy.
Brilliant.
Yes!
You
love these
Markov
things.
chains.
I love Markov chains, yeah.
Why do you love Markov chains?
Because a lot of really smart computer sciencey people talk about these all the time, and I understand them really well.
Amazing.
Yeah. It's probabilities, isn't it? It's probabilities. Yeah.
Brilliant. So a Markov chain is a kind of statistical state machine. Now, the interesting point about Markov chains is that they exhibit a Markov property, okay? The idea being that the probability of transitioning to other states in future is entirely dependent upon the state you're in at that time. So it's, some people refer to it as being kind of memoryless. That's like an intuition to it.
I think I'm going to leave you guys at this point. I'm glad I've helped explain all this stuff to you. And if you guys ever want a job in my cool little startup, then you know, just let me know. You know, we might be able to train you up, and you might be of some use. Thanks, guys.
So a Gaussian distribution. That sounds something like it would be really complicated.
No, but really, it's just a normal distribution. It's just people use the term Gaussian distribution as a way of making it seem more complicated or seem more confusing.
But this just looks like a bell curve.
It's fairly similar to a bell curve. So there is a subtle distinction here in the sense that so a normal distribution, if you sample it infinitely often, ends up looking like a bell curve. So that's a kind of a somewhat idealized graph, but you get the idea.
And what about continuous uniform distribution? That's, again, this uniform distribution sounds like it should make sense, but it sounds a bit more complicated than it should be.
Well, the probabilities of things happening are the same for a whole sequence of values at the same level. So in that sense, it's a continuous uniform distribution. But that's a pretty complex term to use when you're just really describing something that's kind of a straight line when you draw its probabilities of event happening out, right?
Yeah, I think that would confuse me if someone was just bringing that up at a meeting. What about the Poisson distribution? Is that something to do with sushi?
Nothing to do with sushi, nothing to do with fish. So Poisson distribution is an interesting one, okay? Because it's a distribution that's entirely characterized by one parameter. Lambda is what we're calling it here, not to be confused with the earlier lambda. And the idea is that the mean and the variance are both the same property. So if you've got a really, really low lambda, as in the kind of yellow line, you end up, the graph for this ends up looking really skewed to the left because the mean, i.e. the midpoint here, is really low, but at the same time, the variance is really low. So there's lots of things which are really small, distributed really closely together. And then if you have a higher level, if you have a higher mean, and things end up being more kind of spread out, so as you move your lambda to the right on the x-axis at the bottom, the whole graph kind of flattens down until, if you hypothetically had it at infinity, it would just be a flat line.
So when would I ever use this practically, Richard? I mean, this is all good in theory.
Quite a few of these distributions characterize the way different events happen in the real world. So the normal distribution is a really good one, which is kind of frequently, you know, that's why it's called the normal distribution, because it very frequently models the probability of things happening.
So one other thing that someone came out with in an interview the other day was the Kronecker delta. And it confused me.
A shockingly simple concept, okay? So a Kronecker delta is a function where if your x and y input values are the same, it returns 1, and otherwise, it returns 0. Now, interestingly enough, if you represent it as a matrix, it's the identity matrix. So obviously, if you've got a certain value that you have an operation with, then your identity is the value which, if you apply that operation to another value, it returns the same value. So this is kind of weirdly used in some signal processing applications, but it's really complicated, like a Kronecker delta. Why would you call it that?
Yeah, it seems a bit more obvious now looking at the code. What about false positives? I mean, what does that mean?
Well, so there's a really good example of that. So the question of, are there any Java developers in this room? Well, if you said yes for an empty room, you'd be coming up with a false positive. So that is to say, you'd be giving yes as your answer when the answer is really no. And a false negative is a situation where you're saying no, and the answer is really yes. But again, it's quite a simple concept.
Yeah, I mean, I'm starting to remember all this stuff now from back in the day. One of the things I've been doing recently is scouring some of the Adopt JSR and Adopt OpenJDK mailing lists. And one of the things that people seem really rampant about is monomorphic dispatch. That sounds really complicated. I don't think I understand at all.
It's another very complicated term for something that's very simple. So the idea is that a method call's only got one possible implementation. So if you're writing some Java code, you can call methods on interfaces, you can call methods on objects, you can subclass different classes. Therefore, when you call a method, you can have multiple possible implementations. And not all of those implementations are monomorphic, but some are.
Okay, I think I've got an example here.
So here's an interesting example. You've got your list interface, which has got an add method defined on it. Now, if you know that your list interface is only an array list, then your dispatch there is monomorphic, because there's only one possible type that it can actually be. Whereas if you have, say, the option that it might be an array list or it might be a linked list, you've got a polymorphic dispatch, because there's going to be more than one thing.
So where would I practically care about this in my kind of day-to-day, Richard?
Well, it's interesting because you have situations like monomorphic dispatch where, you know, remember earlier we were talking about the hotspot compiler, where you have optimization opportunities for the compiler which wouldn't otherwise exist, or which are very easy to detect, maybe I should say, if it's a monomorphic dispatch.
Yeah, it makes a lot of sense. And another thing that came up on some of these mailing lists was tell call recursion.
Yeah, so it's interesting, actually. The concept of tail call recursion is that, so everyone's very aware of what a recursive function is. It's a function that ends up calling itself at some point in time. And the idea is you've got a base value and you repeatedly call yourself. Now, a tail call recursive function is one that is always recursive on its tail call. So it always ends up calling itself as the last thing that happens before it returns. So there's a simple factorial implementation here, where, so obviously, if your n is 0, you just return what the accumulator is, and to begin with, you pass it in 1. And otherwise, you need to multiply the accumulator by the n, and then pass in n minus 1 to the factorial. So the really trivial factorial that people write in their kind of simple undergraduate classes is not tail call recursive, because it ends up being, you end up, once factorial is returned, multiplying it by n. So it's not actually recalled in the tail position, even though syntactically it looks like it's the last thing.
Okay, that makes a lot of sense. Again, I'm going to ask you one of my common questions. I mean, why would I care?
Why would you care? It's an interesting case, because if you're implementing certain types of functional language which don't actually have explicit looping constructs, then they frequently use the concept of tail call recursion to do a compiler transformation, which then lets you recurse indefinitely without blowing your stack. So if you were doing this as an obvious recursive call, you'd be frequently putting stuff onto your stack. Eventually, you'd run out of space, and then you'd die. Whereas if it's tail call recursive, you don't have to do that. You can do a compiler optimization and convert it into a loop.
Makes a lot of sense. So with the Olympics being on, Richard, I wonder if you could have explained to me a bit about what the trampolining concept is.
I could, but probably not trampolining in the Olympics itself. So there's a few other interesting uses the term trampoline, actually an interesting term because it's a metaphorically used term, but with not an obvious direct relationship to how it's used. But there's a couple of meanings. So firstly, you might be referring to the fantastically well-named indirect jump vectors, okay? So a trampoline in this case is a memory location which holds the address of something else to be called. And the execution jumps to that location, and then immediately jumps to the address which is held in that location. So it's like a trampoline in the sense you jump in and then pop back out again. So that's kind of really used at a low level in order to implement interrupt handlers, low-level I/O code. And the basic idea is that you don't have to assume layout in memory of these things in order to be able to implement those kind of low-level operating system routines. Now, there's also the use of trampoline in what I would say a Lisp situation. So this is a kind of more high-level meaning. So we were talking earlier about the kind of tail call recursion stuff. Now, the idea of just transforming it to a loop is really, really nice and simple if it's only going to support one function calling itself. But if you have a situation where you have some mutually recursive functions, and you want to implement that tail call recursion situation, or you want to just keep on calling functions till the end of time without blowing it through all your stack space and making your customers really sad pandas, then you need to have a more complicated approach. So in this case, the trampoline is a function whose only purpose is to call other functions in the program. So all the functions in the program are entered via this trampoline, and then the program functions don't call each other anymore. They just return the address of the function they want to call back to the trampoline, and they return the arguments back to the trampoline. And so if you think about the way that works on the stack, it increases slightly when you call directly into that function, and then it pops back off when it returns. So you never end up blowing your stack with a huge amount of space. You just end up redirecting that call to another function, but with some performance overhead.
At this stage, I'm thoroughly confused. So what do you think about complex terminology, Richard? What's your experiences?
Well, some things, it's an interesting discussion point, because there are some things which are innately complicated, and there are some things which aren't really very complicated, but we use complicated terminology to describe. Something that's kind of unnecessarily complicated, kind of jargon, that kind of thing. And you're not really helping anyone by trying to make something simple complicated. You're only really helping people by trying to make something complex simple.
So how do you think we should be pitching this when we're building domain objects and starting to analyze business problems? Where should we be drawing the line?
So if you're doing some kind of domain-driven design where you've got like, where you really are living in that kind of sea of nouns situation and everything in your business domain corresponds to some class name, you've got a really challenging problem. You need to establish within your team what things are commonly known, what things are simple. Is it that some piece of terminology is so well known within your domain that it's fine to use it as part of your domain hierarchy, as part of your domain model inside your code? Or is it that this is just something that's unnecessary fluff, and if you're the developer who's trying to translate those requirements into your code, that you don't really care about that complexity, that you can get rid of the buzzwords and the jargon and just use something simpler to explain it?
So I guess it should be simple enough for somebody to be able to pick up a piece of paper who's new to the team, see a list of definitions that are kind of within the business problem, or even then start to look at the code and then quickly be able to figure out exactly what the problem is and what the code's trying to solve.
I'd say so.
So at this stage, does anybody else have any comments on basically how terminology is complicated their day-to-day, or how they'd pitch this kind of business-driven design?
Okay. Well, there's only one more thing to say. You're at a conference. See if you can spot the bluffers who are using too much terminology in their talks.
We'll see you at the bar.